Hello and welcome to the easy button to modernize your on-prem IT operations. Today's webinar is sponsored by ZEDEDA and SUSE and produced by Actual Tech Media. My name is Scott Becker. I'm from Actual Tech Media and I'm excited to be your moderator for this special event. Now, before we get to today's great content, we do have a few housekeeping items that will help you get the most out of the session. First off, we want this to be an informative event for you, so we encourage any questions in the questions box in our webinar control panel. We're going to have a lively conversation between our speakers, and we're going to have a really cool demo, so we won't have time for live Q&A at the end. However, our presenters will be monitoring the Q&A throughout the presentation and are looking forward to answering your questions live in there. So enter them as you have them, and our presenters will get to as many as they can. That Q&A panel is also the place where you can let us know about any technical issues you might be experiencing. A browser refresh will fix most audio, video, or slide advancement issues. But if a refresh doesn't work, just let us know in the Q&A and we'll provide you with some further technical assistance. Second, in the handout section of your webinar control panel, you'll find that we're offering several resources for you to check out. You'll see resources there from ZEDEDA and from SUSE, as well as some links from Actual Tech Media, including our Gorilla Guide Book Club and the ATM Event Center. I encourage you to access those resources now and share them with your friends and your colleagues. Third, at the end of this webinar event, we'll be awarding a $300 Amazon gift card to one lucky attendee on the live event. Of course, you must be in attendance during the live event to qualify for the prize. The official terms and conditions of today's prize drawing can be found in the handout section. Just scroll to the bottom and you'll find the prize terms and conditions link there. And finally, one of the best benefits of this event is the opportunity to ask a question of our expert presenters. And to help encourage those questions, there is another Amazon gift card. This one is for $50 and it's for the best question. At the end of the event, we'll look at all the questions, pick out the best one, and contact that prize winner. And with that, let's get to today's fantastic content. I'm excited now to introduce our all-star panel for today. We've got Jason Shepard, who's Vice President in charge of the ecosystem effort at ZEDEDA. And we also have David Holder, who's a field engineer at SUSE on the rancher side. So it's going to be a great conversation about modernization of on-prem IT operations and how there's more flexibility in your options than you might have thought. Let me turn things over to Jason to get things started.
All right, well, welcome to our webinar today. So this one is about modernizing your on-prem operations. So we're going to talk about how do you extend the public cloud experience or get the public cloud experience at the edge, all of the benefits that you get in a centralized cloud. So with me, so my name is Jason Shepard. I lead our ecosystem efforts here at ZEDEDA. And with me is David Holder with SUSE. Dave, if you want to introduce yourself real quick.
Sure. So yes, hello everyone. My name is David Holder. I work as a field engineer at SUSE. So I help our customers and partners and prospects get on board with Rancher and by extension Kubernetes as a key strategic technology. Yeah,
very cool. So yeah, thanks for joining us. So we'll kind of start with just some of the challenges. I'm sure as an IT professional, these types of challenges look familiar. We're seeing more and more workloads out there in general, and everyone's kind of being challenged to do more with less in terms of budgets and skill sets out in the field. Clearly, with the pandemic, driving a lot of remote workforce, we're seeing more and more need to manage a highly diverse mix of assets all over the place, and that also means that the traditional build a moat around the data center has gone away. So we don't really have a defined network perimeter, which is why we're seeing more and more around SD-WAN and SASE and things like that. Can't forget all the legacy systems that you have, and you can't just modernize everything up straight to more of cloud native technologies. So you want to be able to kind of deal with these types of challenges, but how can you do it, in an easier fashion? And especially when it comes to, you can't have everything move to the cloud over time. And so there's value in being able to improve how you do things even on-prem. And then of course, we're always seeing more and more challenges when it comes to security and how do we maintain the right security posture in your operations. So, of course, cloud, we've seen the huge rise of cloud over the past number of years. It's the easy button. I can switch to an OpEx model. I don't have to have this huge capital investment, and it's fairly simple. You just have to think about resources and you start deploying your applications. There's different tools that you could leverage to build your applications. But the huge trade-off, of course, with like a public cloud solution is that it's lock-in. So this is the fundamental challenge. It's easy button versus lock-in, and the model is it's easy to get data in. It's cheap to get data in, but it's very expensive to keep it there and get it out. And so that can be an issue. If you're locked in, and then you start seeing more and more data flowing. We're seeing this driven by trends like IoT and a lot of different things happening out there where once the data, easy button sounds good until the data starts flowing, and then you might want to pull back a little bit, or at least not be completely locked into a given cloud. And so we've seen over the years like this continuing shift of the pendulum from centralized to decentralized architectures, and the rise of, again, IoT. We're seeing AI. 5G is driving a need for more edge computing because you've got a high-speed local connection, but you still have a bottleneck up the chain. All these reasons, now we're looking at more of this decentralized, or at least distributed architecture. The cloud is not going away. It's not about that. It's just this notion that you need to be able to distribute applications. And there's also just applications that you're running on-prem today that, what if you could have a better way of doing it? And again, get that kind of the easy button of public cloud while also being able to run things and prevent yourself from getting locked in general. And so this is, the milk carton, like very common. We see folks when you're kind of in, say, like a mid-market solution, you're say deploying in a bunch of retail chain stores. It could be branch offices. It could be any number of different locations that you go put out a solution, say it's a small rack of servers or a box in a retail store, and you set it up maybe for like video surveillance or something like that, and you leave and you'll never see it again. You might as well put it on a milk carton. It's missing. You can't afford traditional data center tools, but for that particular solution. So you have like no option for management and security of that box. And so what we're talking about today is how do I get these types of capabilities that I have in the data center, again, that public cloud experience, the simplicity, but be able to do that for resources out in the field that are highly distributed and of different scales and sizes and whatnot, so that you have remote visibility and control over all of these different assets and do it in a simple way. So first we'll talk a little bit about ZEDEDA and what we do, and then David will share from a SUSE Rancher perspective, and then we'll kind of go through how better the two solutions are better together. So effectively, what we offer at ZEDEDA is a cloud managed operating system. So it's you can deploy our solution at any edge location. And it's about that underlying infrastructure management, that foundational security, that then you run your choice of applications on top. And David will talk about how we're working with SUSE in terms of Kubernetes, but it really can be any type of application, including legacy apps that can run on top. Say you have some Windows software like point of sale or video management solutions or anything like that. They can run on top just as well. We sell our solution as a subscription. So it's effectively a SaaS-based, cloud portal that you subscribe to. And that's where you go in and manage all of the different hardware, the nodes that you have deployed out in the field, bootstrap the underlying clusters, which then, like a Rancher console would do the ongoing cluster management, full visibility into the hardware resources and utilization, updates of both the operating system and all the applications. At the edge is a operating system that we leverage from Linux Foundation. It's called EvoS. Think of EvoS as it's very curated. It's not just Linux. It has an embedded hypervisor in it. A lot of features around security that I'll dive into a little bit more. But think of EvoS as like do for Edge what Android did for mobile. You create an open operating system that meets the needs of distributed edge computing, on-prem compute, and then build an ecosystem of hardware and applications around that. And so EvoS on edge hardware is what then is leveraged by ZCloud, our cloud offer for orchestrating both the hardware and the applications. And again, we'll kind of continue to build on that as we go. So what we've done from if you look at Edge as a continuum, you've got super constrained devices on the left, could be a smart light bulb or a thermostat, some sort of sensor. On the far right, you've got regional data centers that typically operated by like a service provider. And there's this kind of continuum in between. And what we've done from a architecture standpoint is extended this notion of abstraction of hardware, the easy button of SaaS, all of those benefits from a public cloud standpoint, and moving it as far left as possible until you just can't support that workload abstraction. You run Linux and VMs and containers and all that kind of stuff. That's cloud native principles. And so, our footprint from an EvoS standpoint is 512 megs of memory and disk. And so any box that has that plus whatever you need for applications, you can go from there and scale up. So gateway, hub, router, cluster of servers, it doesn't matter. As long as you have enough resources to run EvoS, then it scales up, into, higher and higher classes of resources. And then of course, SUSE, there's all kinds of different tools from a data center standpoint, but SUSE with K3S and of course Kubernetes in general, pioneering that space. And so we started at the lowest common denominator before you just have to go embedded, and we are merging with these great data center solutions, and of course all the work that SUSE is doing on Edge as it comes down, and we become a foundation to be able to deploy those types of solutions. What's different is when you're in a data center, you can assume a defined network perimeter, at least way more defined than out in the field. You can assume physical security. The controller can call the box itself and say, hey, this is the software you should be running. When you're out on-prem, but you still want to remotely manage things, you have to assume you're going to lose connection to that box from time to time. You look at a lot of different offices, they might not have constant connectivity, retail stores, whatever. You have to assume that someone can walk up and touch that box. And so the way you do security has to be different. And the boxes have to be able to phone home to the controller and say, hey, this is what what should I be running? And you set the state in the controller, and it updates that for the fleet of devices out there. So it's a similar principle to data center and centralized data centers, but the operating model has to be flipped. And so again, we've optimized for that on-prem solution that then bleeds into the data center paradigm. Kind of IT 101, separating out infrastructure plane from application plane. We're 100% infrastructure on the ZEDEDA standpoint, underlying hardware and kind of deploying software runtimes. And then SUSE, as David describes it, they're also infrastructure, but kind of in that application framework and cluster management. And then of course you take your pick of applications on top, and it fits into your existing deployment profile, CI/CD profile and whatnot. But important that we're not, neither of us are really we're not in the data path. The content, the data, the applications, that they're yours. We're just simplifying how you deploy things out in the field, including working with legacy software. So we'll do a quick demo as we go towards the end. But these are some screenshots from ZCloud, but you'll see it a little bit more as we go live. But it's all about give me that central management, give me that full visibility across all of my locations, manage that underlying infrastructure, and that could be any combination of workloads. Again, we sell ZCloud, that's the subscription offer, and then EvoS from LF Edge within the Linux Foundation. This is the Edge operating system that would run at the bare metal level that gets down into silicon root of trust and a bunch of security features that I'll highlight here shortly. And then we have an ecosystem of hardware providers that we work with the beauty of once you have EVOS on a box is you literally plug in power and networking on site, and then you can leave. You don't have to have any IT skills on site. You just you bootstrap it. The box itself then phones home to ZCloud. It leverages the root of trust in the box. So say like a TPM 2.0, it creates a crypto-based ID from that box so that you no longer have a username and password locally, because that's one of the threat vectors when you're on premise. People just start randomly hacking at a box and start trying to sideload software. Does measure boot, remote attestation, has distributed firewall capabilities, and you can even turn off individual ports and reroute applications to different resources. All of the resources are virtualized, which is again that public cloud experience. I don't want to care about the box. I want to care about resources. I need this much virtual CPU, this much memory, this much storage for a given application. And so Eve creates that layer of that enables the granular policy control, and then you do all that through ZCloud on the back end. There's an integrated app marketplace within ZCloud. Think of that as like the Google Play Store analogy to the Android analogy of EVOS on the edge node. And we have Kubernetes within that, the K3S, and again, you'll see the integration with Rancher as we go. But it really is about providing a turnkey solution to manage your infrastructure out in the field with your choice of applications. The data goes wherever you want it to go. It can stay on-prem. It can go to the cloud. We just provide that kind of open, agnostic foundation for your solutions. And the key here is, because EVOS is vendor neutral open source developed within the Linux Foundation, if that's your insurance policy from getting locked into even ZEDEDA, we've done the hard part of creating a controller, but anyone can build a controller to EVOS. Again, it's that Android analogy. Proprietary bare metal, so this is where it's kind of similar. You've got the benefits of a bare metal abstraction point above the hardware, but you're locked into that solution. And on the other side, if you have an agent-based solution, there are management solutions that say, "Oh, take my agent, put it on whatever operating system you want," which sounds great until you realize that if you don't do a lot of work to harden that operating system or integrate the agent really tightly with it, it's very likely you will brick that device in the field or have security issues. So effectively what EVOS is we've integrated an agent tightly with a very, very curated operating system to make and then made it fully open to make it kind of the best of both worlds. So again, you can run any combination on EVOS of virtual machines, full Linux images, legacy Windows apps, native containers. You choose your guest OS. David will talk a bit about Sleep Micro and some of the work from the offers from Kubernetes or from SUSE Rancher, and all of that applies in terms of running on top of Eve, orchestrated at that lowest level. And the demo will show kind of how what work you would do in our console to kind of bootstrap the field devices and then and form the initial clusters, and then how you would go over to the SUSE Rancher console to do ongoing cluster management. So I talked a little bit about the security, but it's layer upon layer of security that's all sort of built into the solution, down the silicon, all the way up through measure boot, remote attestation, all the certificate management, this notion of being able to lock down individual ports. I want to shut down all the USB ports. I don't want anyone to access these serial ports, et cetera, except for when someone needs to work with it on-prem, but even then they have to go log in through the console. We have the ecosystem available where you can deploy different applications. So of course, there's the work we're doing with SUSE, but then we also have applications, say you want for SD-WAN, like we work with Juniper Networks and Palo Alto, and there's security plugins that we have from like Nozomi Networks and Guardian or from Microsoft. So a variety of different plugins that you can get from the App Store, and then of course we've got traditional RBAC and all the certificate management on the back end. Plus, we are SOC 2 certified. So all of this is integrated into the offer, so you don't have to really think about kind of how you you architect the full security stack. Within EVOS, there's this distributed firewall capability I mentioned, where you can literally say that this application is dedicated to that GPU, this one for these 2 CPU cores. This app can only talk to that app on this box. This one can only talk to this backend, this IP address. So very, very granular control that you can set in Zed Cloud, and then that's policies driven to all the applications. We don't store your applications. We store deployment manifests of the apps. So our marketplace, when you get into the marketplace, there's a kind of a public version, and then you can curate your own private version that has the content that you want, whether you're an end user or say you're a system integrator or some sort of OEM and you want to offer it. But if it's your business and you're trying to modernize your IT operations, you can put all the applications that your end users will be using in the field, or your business will be using in the field. And then one of those apps, of course, that's available is our K3S instance that Dave will expand on. We see so at ZEDEDA, we've done a lot in the industrial space, manufacturing, oil and gas, renewable energy, things like that. I kind of call that OT up, where it's kind of more IoT focused. You might have IoT gateways sitting right above the control layer. You have different security nodes placed within on the operations side and whatnot. But we also see a lot of use cases, what I call IT down, where you're coming in with these cloud technologies and you're bleeding them into the on-premise locations. These can be CPE equipment. You could have like some sort of network appliance sitting at the kind of top end of the network, drop-in appliances or different types of hardware to consolidate workloads anywhere within your business. Security-focused appliances, all of these types of use cases we can support with this base solution. And that can include, again, any combination of your existing applications plus new things that you're developing over time. So you don't have to move everything to cloud native right off the bat. So here's an example. So like in retail, say you have a video management solution. A lot of them today are Windows based. I want to run that alongside some AI models, say for facial recognition, demographics within the store. Maybe I want to use Azure IoT. Tie that into some different systems within the buildings that those might be virtualized as well. And all of these different types of applications can be deployed on one box and consolidated. And then of course the same thing applies when you get into forming clusters and whatnot, which David will talk about. So really, and in doing this, you don't have to think about the hardware. It really is basically resources to you, and all of that complexity is abstracted. So with that, I'll hand it off to David to run through the SUSE offer and all the great things they're doing.
Excellent, thank you very much. So for my part of today's presentation, I'll be kind of going through what SUSE's approach has been to addressing the challenges at the edge, and kind of also how we can work with ZEDEDA to provide a comprehensive solution. So next slide, please. So challenges at the edge. So the first challenge that organizations usually face is the lack of edge solutions with full lifecycle management that not only covers the application layer with containers, but also the operating system and those unique requirements that we find at the edge. At a high level, organizations observe that there are technology silos as you move across from core to cloud to edge. This makes choosing technology for edge computing tricky, as you could be adding further silos to this. From a security perspective, how do you ensure security for all operational aspects of these edge devices, keeping them secure for years to come and to stay compliant with industry-specific guidelines? Edge use cases exist in almost all industries today, so how do you pick a technology stack that will meet your specific needs? Next slide, please. So keeping the issue of scale in mind, let's look at one of the key technologies that you would use for edge deployments, for example, Kubernetes, and why it is a suitable choice. First of all, for a variety of reasons, the applications you would run on the edge will already be packaged inside a container. Many organizations are adopting a container-first approach to application development and delivery due to its inherent benefits. The majority of companies using containers leverage a container management platform today to deploy, orchestrate, and scale their containerized workloads. Kubernetes has emerged as the dominant technology due to its flexibility and scalability. So there's no longer a decision point about which container management platform to use. Kubernetes has become the de facto standard. Next slide, please. Challenges with Kubernetes at the edge. So despite choosing Kubernetes as the management platform, there are still challenges. So for example, Kubernetes is not tailor-made for edge applications. It has a broad use case as a container management platform. Complexity in using and operating Kubernetes is one of the biggest, if not the biggest, hurdles for organizations when it comes to edge applications. Edge use cases also require technologies that have a small resource footprint and need to be highly flexible. So off-the-shelf Kubernetes distributions may not fit the bill for every use case out there when it comes to the edge. Next slide, please. When it comes to additional complexity challenge, so based on the profiles and use cases, we see there are kind of two challenging areas at the edge. One is the native complexity brought in by Kubernetes, and the second is the sheer number of edge locations under management. So when you combine these two challenges, the complexity and large numbers, you essentially need a framework that can address these challenges as and when required. Next slide, please. So to attack this, we've kind of developed a special type of vernacular inside SUSE for addressing the needs at the edge. And because the edge is such a kind of diverse environment and very kind of broad in terms of its adoption, we've had to kind of subcategorize it. And we've done this by labeling certain edged environments as near, far, and tiny edge. Next slide, please. So although the concept of edge computing is decades old, investment in Internet of Things devices have moved edge topologies into the spotlight. Edge computing places resources closer in the proximity of the source of data. And depending on where the edge infrastructure is located, we can segment the edge landscape into three logical areas as what we call near, far, and tiny edge. The first edge segment that we encounter in the realm of communication service providers is likely the near edge. We call this the near edge as it's the nearest to centralized services. The next segment we encounter is the far edge. Here, the IP space and infrastructure are typically owned, operated, and managed by the end user organization. Here we find a diverse set of use cases. Broadly, these fall into commercial, industrial, or public sector deployments and can reach numbers into the tens of thousands of locations. And then lastly, we have the tiny edge. This segment represents the world of fixed function devices or industrial Internet of Things. The tiny edge is where the law of large numbers tends to kick in. Next slide, please. In terms of mapping certain industries to these particular edge environments, we've got some examples here. So at the near edge, so where we are closest to centralized processing, we may find, for example, service management and observability, 5G core as examples. But by far, the far edge is what we would consider the kind of most applicable or the most widely seen. So here it actually spans a number of different industries, organizations, and challenges. So we have, for example, manufacturing and retail and intelligence community-based workloads that we need to address. And then, of course, we have the tiny edge. So this is where we have very specific functions. So for devices like actuators or IP cameras, something that Jason mentioned earlier. Next slide, please. So in terms of addressing this in a kind of roadmap scenario, so classic and cloud native use cases, organizations are at different points in their journey and digital transformation. As you go from left to right in the picture above, you are moving from cloud ready to cloud native technologies. A cloud ready or cloud enabled application is built from software that has been modified to run on a cloud computing infrastructure platform. An example of this would be an application located on premises that has been, for example, lifted and shifted into the cloud. Some of these organizations are transforming their mission critical workloads without containerization. They could be using virtual machines or bare metal, and these are represented on the left side above. Some are transforming using containers, but the application workloads could be more suited for data center or are more centralized. These organizations would benefit from the adoption of Kubernetes still. And in the center, you would run into organizations which have a blended use case. For example, are using hybrid IT, as well as using cloud-native technologies. They would use a mixture of these technologies. As you continue to move towards the other end of the spectrum, these organizations are using a lot of cloud-native technologies for their edge use cases. They would like to have a full cloud-native stack that is integrated as well, along with being able to manage everything from one management tool. And this is where the Rancher management platform would sit in as their kind of single dashboard to manage their entire edge stack. And next slide, please. So in terms of transitioning and using containers and Kubernetes to address edge problems or edge use cases, we recommend a 4-step approach to secure this kind of transformation. The first is to move on from legacy systems. So devices and systems based on legacy operating systems, whether Windows, homegrown Linux, or some other niche approach. They are expensive to maintain and restrict productivity. Security is implemented sometimes as patchwork and lacks a cohesive framework for the entire system. To containerize, so to transfer applications to run as containers. Containers provide a consistent way to package application components and their dependencies into comprehensive objects that we can run in any environment. Containers make it easy to build workflows for applications that run between multiple environments, enabling the smooth operation of almost any hybrid environment. Using containerized applications sets the stage for applications to be developed at scale with consistency and performance and reliability. We then also suggest to use Kubernetes. So as more containers are deployed throughout an organization and their cloud environments, IT and OT teams need a way to keep track of them to develop and deploy at scale. And Kubernetes makes it easier to manage this software complexity. And then lastly, to adopt cloud-native methods. So cloud-native technologies empowers organizations to build and run scalable applications in modern dynamic environments such as public, private, hybrid cloud, and at the edge. Containers, service meshes, microservices, immutable infrastructure, and declarative APIs exemplify this approach. These techniques enable loosely coupled systems that are resilient, manageable, observable, and can be more secure. Next slide, please. So our approach is born in the cloud. So keeping the perspective of complexity at scale, we took we both have taken a customer-centric approach to addressing edge use case. What do the customers have today and what do they need for tomorrow? With these two design goals in mind, come up with to remove complexity, so deployment, administration, operations complexity, and also to the design for scale. So here at SUSE, we're creating an open source cloud native solution with 3 essential foundations. The application layer, so Kubernetes ready, lightweight, cloud native edge stack. The operating system layer, so our operating system is purpose built for the edge. And then we also have full lifecycle management of edge devices. So the idea is to aim for maintenance-free infrastructure so you can reduce operational friction, improve operational efficiencies, and gain economies of scale. Next slide, please. So our open interoperable edge solution. So we provide an open, lightweight software infrastructure for building, deploying, and managing cloud-native applications across all your edges, be it near, far, or tiny, and connecting those edges to your clouds, both private and public, and to your data centers with automation, security, and a common management framework. We also are delivering SUSE Linux Enterprise Micro, built specifically for the edge. It's an example of a lightweight operating system that's usually used in tandem with something like K3S. This means that you can confidently innovate at the edge and ensure that you have the best of breed tools available to you to tackle your particular edge use cases. Next slide, please. So we both utilize K3S. So K3S is now a CNCF project. It was originally designed by the Rancher team, and obviously we got acquired by SUSE, but effectively it's now been donated to the CNCF. And it delivers lightweight Kubernetes fit for constrained and remote locations for IoT devices. So it was donated to the CNCF in 2020. K3S as a standalone distribution is production ready and is packaged as a single binary. It is also cross-compiled, so you can run K3S on standard x86 hardware as well as ARM64 and ARMv7. Longhorn is also now in CNCF project and is used to deliver a distributed software-defined storage platform for Kubernetes, so we can run persistent workloads on the edge. And Longhorn itself also supports both x86 and ARM architectures. And Longhorn is the first Kubernetes native storage solution kind of designed for these edge cases in mind. Next slide, please. When it comes to an operating system, so here at SUSE, we offer a cloud-native variant of SLE Micro. This is our lightweight and secure operating system kind of built from the ground up for edge applications. SLE Micro leverages the enterprise hardened components of SUSE and Linux Enterprise, so you get a reliable infrastructure platform that's simple to use and comes out of the box with best-in-class compliance. Security is also baked in, so with SLE Micro, we have a read-only file system, immutable operating system design, integrated security framework using SE Linux. Integrated security framework for the edge device is also applicable for this particular operating system. So we can help IT operators in building a secure edge infrastructure with proper access to controls in place. Workloads are also isolated from the core file system to guard against malicious applications compromising the system. Security integration is key, with the container runtime is adjusted to support auto-generation of SE Linux policies for our containerized workloads. Compliance with industry standards, so for example, FIPS 140-2 sets a baseline for security of overall system architecture for edge deployments. As a result, the end-to-end edge infrastructure gets designed to be secure out of the box. Next slide, please. So moving on to some success stories we have here at SUSE when it comes to our customers leveraging or have the edge as part of their strategy. So the first is Hypergiant. So Hypergiant Industries focusing on solving challenging problems by delivering artificial intelligence solutions and products. So this company creates emerging AI-driven technologies for the likes of Fortune 500 and government clients working in a wide range of different sectors, including space, science and exploration, satellite communications, aviation, defense, healthcare, transportation, and a lot more. So Hypergiant and SUSE are working together with DoD Platform One to demonstrate the benefit of DevSecOps. Kubernetes, together with AI and ML apps in remote and often disconnected environments, working with K3S, again, a lightweight Kubernetes distribution, now a CNCF project. The team is developing and integrating their software pipeline with Edge One and Satellite One missions, including the launch of Hypergiant's Kubernetes-enabled satellites. Next slide, please. The next success story I have is Continental. So Continental is present in 59 countries and markets and has more than 200,000 employees around the globe. Continental did run a virtualized infrastructure for many years, which did suit them pretty well. But over time, management and maintenance became problematic. If teams wanted to implement a new feature or upgrade an application, this was time and resource intensive. Latency was also an issue where some critical applications were concerned. Factory machinery requires millisecond response times. Therefore, some systems would need to remain in the data center. As such, the team needed a hybrid cloud and on-premises methodology. Continental's manufacturing teams needed a way to run multiple clouds and on-premises deployments side by side in one platform, and that's where Rancher came in. Their project team has created a highly agile and scalable application framework, which has removed complexity and significantly reduced management overheads. The new containerized architecture allows them to run applications in separate clusters with development, test, and production environments already in place. If they need a place to spin up new containers to try out new ideas, then they can do so in minutes. If an application needs to be updated, a feature added, or maintenance performed, this can be done using Rancher without halting production lines. The team no longer requires costly maintenance downtime during upgrade periods. Next slide, please. And Jason, I believe this is where I'll hand it back to you.
Yeah, cool. Great. Thanks, David, for the overview. So, yeah, just to kind of summarize how we were working together, as I mentioned, ZEDEDA is 100% focused on that lower level infrastructure management, security down to silicon, layer upon layer of security functionality, the distributed firewall capability that I mentioned. Think of EVOS as a thin shim that's bare metal, that all of the goodness that David walked through from a Kubernetes standpoint, the Rancher console, that would kind of run on top. I mean, including SLE Micro can run on top. And of course, as you mentioned, they've done a lot of hardening and compliance around SLE Micro as a guest operating system for their Kubernetes offer. But likewise, you can also say you have Windows applications that you want to run alongside your clusters. ZEDEDA can support those just as well. Other Linux distributions. So together we offer this combination where you have all of the advantages of modern application development. All the advantages of Kubernetes that SUSE and Rancher know really well. But also can just kind of modernize and lift and shift your base operations at the same time and get entirely new security benefits and benefits around how you segment data on different networks and the network flows because of that built-in distributed firewall. So the demo that we're going to show is basically how with the ZEDEDA console how it makes it really easy to form clusters at a particular location. That underlying bootstrapping of getting the K3S distribution onto those boxes, just from bare metal. And then it will flip over to the Rancher console and show some of the integrations that we've been doing between the two. So you really have that kind of better together story. So you would bootstrap with the ZEDEDA console, your Kubernetes clusters or any other types of runtimes that you want to run, and then you would kind of live in the Rancher console in this case for your application management and the cluster management over time. And then that separation of concerns gives you kind of the flexibility to evolve as you go. So we'll play the demo and then we'll be right back.
In this screencast, we will go over ZEDEDA's SaaS portal and how it lets you manage your edge node, orchestrate your edge applications on those edge nodes. We will specifically look at how collection of edge nodes can be brought together to orchestrate a Kubernetes cluster. One thing to keep in mind is that the ZEDEDA offering is limited to orchestrating of the Kubernetes cluster. The clusters can be stitched to a management tool like Rancher for activating any application workloads. So let's go into the details of the cluster instance. So if you go into the cluster instance here, you will end up seeing the two cluster instances that are active. So one of these particular cluster instance actually has orchestrated Kubernetes. This test cluster instance is an active state, and it is actually has a edge node pool size of 1. That means this is only one device which is basically forming the Kubernetes cluster. That means there are multiple VMs being placed on one single device. Of course, in order for you to achieve high availability, you would want multiple devices to be part of that particular Kubernetes instances. And let's go into the details of the multi-device cluster instance, which basically has two devices. So as you can see here, these are the two devices that create a Kubernetes cluster. One of these particular devices has a role of a server, which is also called as a seat server. The seat server acts as a master in Kubernetes, and that basically has the API server running, and that is running on an edge node called BLR, Supermicro ZC4. And then there is an agent node, which is actually going to have application workloads on there. So you could just simply click on these particular edge app instances to see what exactly is going on these edge apps. So if you click on those particular app instances, you can see the master, which is in an active state, and it has been up for quite a long time. And you can see the basic info and different pieces of information on how this thing looks like. So this is the environment in which the master is running. And you can also see, what all particular adapters. So it has one adapter, H0, which is connected, and there are different events that have happened on this Edge app instances as it came online. You could see that, hey, you know what, it was in a created state, then it got into the active state, and it continues to generate different events. Right from your fingertips, you can actually go and take a look at all the logs that have been generated for this particular app instances. So this is an extremely powerful feature where you have remote cluster and the cluster misbehaves, and you want to go and take a look at the logs and whatnot, right? These information is directly available at your fingertips using our orchestration pieces for your cluster instances. So going back to the cluster instances, you will see, hey, you know what, you can, if you had like 5 devices acting within a cluster, you will end up seeing all these particular things right here. So you can also go and get similar kind of information on the edge instances which are running for the agent node. That means, the workload scheduler nodes. So as I mentioned initially, we do allow orchestration of Kubernetes cluster. However, the main stitching of application workloads on how to push the application workloads on these clusters is done using Rancher management. So in here, I'm going to show you this multi-device cluster, which we went into detail of, and how this is actually stitched to Rancher. So here you can see I'm logged into Rancher, and if you go into the clusters of Rancher, you will see this multi-device cluster. And if you go into the details of it, you will see, how this whole thing is stitched together with Rancher. And you can see all Kubernetes managed objects in the kubeconfig and kubectl that you would want to accomplish are all stitched together with Rancher. So once you have a cluster active, we can of course have different actions associated with the cluster. You could deactivate a cluster. That means you just want to bring that particular cluster in a deactivated state, so that you can perform any kind of a management operations or a backup and restore or any other kind of operations, and then subsequently you can activate those particular clusters again. This is not dismantling of the cluster, but this is just partially making sure that the clusters are in a stopped state, so that you can do any kind of a management action, and of course delete a particular cluster. So these actions are available to you right from here. Now let's go and create a brand new cluster and see how the workflow for that looks like. All you need to do is just press this plus button, and you will end up seeing a widget or new workflow which will allow you to create a cluster. So let's say I call it like a my demo cluster, and I give it a title, give it some description. Here is I can actually give a key value pair to tag this cluster. If I'm interested in searching, I can give a tag to this particular cluster instances. Now I am being offered a lot of these particular devices that are available in this project. So in order for me to search for these particular devices, I can put a key value pair, and this will allow me to search and hone in on the edge node on which I want my cluster to be placed. So I have picked a edge node for this particular location. The key for that was a location and the value is east. As soon as I put the tag on the search criteria, I'm offered a edge node which I can pick up and make it as part of the cluster. Then I can actually put the runtime. This is what kind of a Kubernetes VMs I'm going to be pushing to these particular cluster. I can pick up a particular VM. It gives me a structure of how my hard disks, how my network adapters and other pieces are going to look like for this VMs. I need to just pick up the right tag, and this is a little bit of a configuration that I can actually configure my cluster for. Once I have done that, so I can actually put some configuration associated with the cluster itself. So this lets you actually provide you with a definition or the manifest endpoint on how I can connect with Rancher. I can give the minimum number of server nodes that I would like in the cluster, the maximum number of server nodes. So if you want to constrain your edge to be not more than a certain number of devices, you can mention the maximum number that you want. What type of a minimum agent nodes that you would want, depending on the workload and how resilient you want the workflow to be. You would want to control the minimum number of agent nodes. You would want to contain the maximum agent nodes that you have in the system for this particular cluster. What will be the minimum number of edge nodes that you would want in the system, and what will be the maximum number of edge nodes. So this is your cluster policy, which basically makes sure that you always are constraining your clusters and your clusters are not running haywire when orchestrating. We will make some intelligent decisions based on that. We will actually make sure that your agents and other things are fairly distributed, so that your orchestration is successful and resilient, just like what you want your Kubernetes cluster to be. And after you push this information, all you need to do is submit, and this will activate your cluster according to the cluster configuration that you have provided. And that's it. That's all you need to do in order for you to activate your cluster on ZEDEDA. It's fairly simple, and this lets you build really complicated configuration and takes out the headache of orchestrating. One important thing to think about is that any type of upgrade in terms of new releases of Kubernetes come in, you should be able to manage that whole cluster life cycle here.
Okay, so we'll summarize real quick and then kind of wrap it up. So between the two companies, we're offering a comprehensive package, and it gives you a lot of different choice and flexibility in how you do things. This is, as we've been saying, it's really about how do I get the benefits of public cloud in terms of I don't want to think about hardware. I just want to look at applications, and I want to deploy those to certain types of resources. I want to consume it as a service, as OpEx. I want to be able to do it without having specialized skills throughout my business, and I want to do it all remotely and be able to manage the whole stack from down to the hardware itself up through clusters and all the different things in between. I can't forget about my legacy applications. So both ZEDEDA and SUSE Rancher provide options there, and we can kind of provide a tailored solution depending on your organization. Of course, security matters, and it's really about how can I do more with fewer resources, both in terms of dollars and people, especially when it's remote. David, if you wanted to summarize a little bit on the SUSE side.
I mean, absolutely, yeah. So just the culmination of both of our technologies can provide a pretty robust kind of way to address those challenges. So, I mean, obviously at the edge, the field is changing every day, we find. So I'm sure it's the same for you, Jason, but kind of every week there's a different use case cropping up, a different challenge to address. And anything in the containerized world also is moving at an incredible pace. So there's always solutions and challenges for us to address. And it's also quite exciting, I find, to kind of build these solutions to address these challenges and to see the outcomes being generated by both our platforms.
Yeah, definitely a lot's changing. And, I think the theme for today is, even as things are changing, how can you do what you do today better in the purest sense, and then better prepare yourself for new types of applications, and how do you continue to innovate in the future. So you kind of, again, it's easy button to do better what you're doing today, and then be prepared to continue to modernize as you go. And basically what we're doing, is by David mentioned it's the near edge, far edge, and tiny edge, is we're extending that public cloud experience deep into the far edge before you just have to go embedded with the tiny, as he was saying. So with that, we'll wrap up. We appreciate you guys listening in, and you definitely reach out to us if you have any questions. We'd love to help you with modernizing your operations and you have lots of different options, as we said, and give you the benefits, as we went through. So with that, we'll have a good day, and we'll see you out there.
Jason, David, thanks both of you for coming on today. It was a really great presentation, an enlightening conversation, and a good demo to boot. So we really appreciate your time today. And before we wrap up, we have one more piece of business. It's the $300 Amazon gift card prize drawing. And the winner of that $300 Amazon gift card is Bob Basey from California. That's Basey, B-A-S-I. Congratulations to Bob. We'll be in touch to get you your card. And with that, on behalf of the Actual Tech Media team, I want to thank ZEDEDA and SUSE for making this event possible, and to thank all of you for attending and for submitting your questions. That does it for today's event. Have a great rest of your day.